The world of IT security goes well beyond our individual systems. Now, when you think about a desktop computer, what does a desktop computer offer you? For example, one of the things it offers you is that you can put different operating systems on there. One Intel processor could easily run either Linux or Windows and a lot of subversions within that. The other thing that a desktop has is that it's expandable. I can swap cards in or out depending on what my needs are. I can add memory. I can add or remove disk storage. There's a lot of flexibility with a desktop computer. So when we talk about a desktop computer, we tend to treat that as a general computer, a workstation computer. But there's a whole other class of computers, and that's what this episode is all about. Now, on the Security Plus, they break it down into embedded, specialized, and mobile systems. But in the world of Mike Myers, these are all pretty much the same type of systems, what I call all of them as embedded systems. Now, when I say an embedded system, what I want you to do is think about different kinds of computers and compare them to a desktop. For example, with an embedded system, you usually have very fixed hardware. So your iPhone, for an example, is a great example of an embedded system. Now, Security Plus may call it a mobile system, and it's mobile, I'm not going to argue that. But it's also embedded in that the hardware is very fixed. The other thing an embedded system is going to have, it's going to have a specialized use. You're not going to use that iPhone to play super advanced games, for example. And you don't have the flexibility to change stuff out very much. It's a phone. You use it to talk to people, to text, to do some basic web browsing, and get on Facebook. So when we're talking about an embedded system, it tends to be very, very specialized as well. Also, the last thing on an embedded system is that it tends to have a fixed operating system, a specialized operating system just for that type of computer, and it's not so easily changed as we could with a desktop system. Let's start with probably one of my absolute favorite, and that is a Raspberry Pi. So this is a little Raspberry Pi I've got right here. Now this is what we call a system on a chip. Whoops. If you look at that, underneath this right here is an individual chip, and on this one chip it has CPU, it has RAM, it has basic storage. It can do everything. It literally is a system on a chip. It has basic input-output. So all of these little connections to things like USB and networking and all that are all being handled through that one little teeny tiny chip. If you're going to be running things like a Raspberry Pi or one of the Raspberry Pi's competitors, Arduinos, these systems on a chip are going to have very fixed operating systems. For example, with Raspberry Pi, they actually have something called Raspberry OS that you almost always run with it. And you're not going to be changing the hardware. Now, granted, with a lot of these, if you take a look right here, you'll notice that this has these I/O. I can plug LEDs and relays and things like that in there, but the system itself is very, very fixed. The next type of embedded system I want to talk about are industrial control systems, or an ICS. Let's face it, everywhere out there, if you're making donuts or mousetraps or cutting wood or whatever it is, there's probably a dedicated computer involved with that process. And that's what we're talking about when we talk about industrial control systems. These are the computers that run the machines that make bagels and cut wood and all those different things that we need in our lives. So with an industrial system like that, number one, it's going to be usually going to run what's known as a real-time operating system. Microsoft Windows is not really a real-time operating system. When we say a real-time operating system, we're talking about operating systems that are out there. You may have heard embedded Windows, for example, that are designed to run at real time, to be dealing with whatever might be happening. So whenever you're talking about ICS, real-time operating systems comes into play. Now, we could take that a step further and go into supervisory control and data acquisition systems, better known as SCADA. Now, a SCADA system is kind of like an ICS with one big difference. SCADA systems are designed to be run over long distances. Like, for example, a computer system that supports a railroad line or electrical power lines or a oil pipeline out in the middle of Kansas that goes through 3 other states. Those are what we call SCADA systems. Yes, they are industrial control. They're going to be running pumps or whatever you would need, but they do it from a pretty long distance away, and they usually have some amount of AI so that they can handle a lot of problems on their own. The next type of embedded system is probably one we all know and love, and that is Internet of Things. When we're talking about Internet of Things, like this would be one example right here. So this Amcrest camera is an Internet of Things. Number one, yes, this is a camera and it's got point, tilt, and zoom on it, but more importantly, it's got an operating system in here that's running a version of Linux, it's got a CPU in here, it's got some RAM in here, it's got storage, it's even running a web server, so if you want to query the camera, you just type in its IP address in a web browser and you can see whatever the camera is seeing. The thing about Internet of Things is that what makes an embedded device an IoT device more than anything else is that it can connect to the internet one way or another. And you can see on this guy right here, I've got an RJ45 connection. And by the way, this guy also does wireless 802.11 as well. So there are some very interesting security issues when you start dealing with the Internet of Things types of devices. Remember, bad guys could get to this. In fact, this particular camera was notorious for a particular vulnerability a few years ago that is well documented. Check out Amcrest camera vulnerabilities, and you'll see that there was some problems. They're all patched up and everything, but definitely a big security issue right there. Now, there's other ones that the Security Plus calls specialty type systems, but to me, they're also very much embedded. Probably one of the big examples of that would be medical systems. You can't run an MRI or about any machine anymore without directly dealing with some form of embedded system. Certainly running real-time operating systems, these types of devices are designed to let the MRI machine do what it's supposed to do, or X-rays or anything. This is all extremely automated type stuff, all running embedded systems, and they're all going to have CPU, RAM, operating system, the whole shebang. Along with that are in-vehicle computing systems, and anybody who's been dealing with a car in the last few years probably has dealt with in-vehicle computing. Now, I'm not just talking about wonderful things like Android Auto that will allow me to sync my playlist from my phone into that, but more so even the ability to be able to query the system for diagnostics, and even ultimately to make a system where it doesn't even need people, self-driving cars. Now, one of my favorites are unmanned aerial vehicles, or UAVs, better known as a drone. I love this little drone. It's not much, but boy, this thing does a lot. Anyway, a drone system is obviously not just a radio-controlled device. It certainly has radio control to it, but more advanced drones, not that much more advanced drones, for example, the ability to hover on their own, the ability to follow you. If you're holding a device that's controlling it, it will just follow you around if you want it to. You can set the height, the time, loiter time. If it starts to run low on batteries, it can be programmed to land within a certain amount of time. So there's a lot of features built into drones that very much also make them embedded systems. Now, one of the cool things about living in Houston, Texas, is that we are one of the few cities in the United States that actually uses smart meters. A smart meter is a device, it's almost always an electrical meter, and that's what we have here in Houston. And if you take a look at this meter right here, it looks like a regular electrical meter, right? But boy, does it do so much more. These smart meters are reporting back to a central area how much power they're using, at what time on like a per minute basis the power is being used. They're incredibly useful. And here in Houston, I can actually query my own smart meter through a website and determine my power usage. I can even compare that against the power company who's charging me and say, hey man, that seems a little bit different. So smart meters are absolutely amazing. Smart meters give us the ability down the road to be able to do things like, for example, I don't think it's that far away where we're going to have an electric company go, look, you've got a smart meter. If you let us control your smart meter within this particular range, we'll give you half of the cost. We will literally cut your electric bill in half, but if it gets a little warm, we get to turn up the heat. And then it's a matter of your personal choice whether you want to use something like that. So that's pretty impressive stuff, but still a little bit in the future. Now, along with this are going to be surveillance systems. Now, you might want to look at this little IoT camera and go, well, it's a camera, isn't this a surveillance system? A surveillance system is certainly going to be cameras, but it can be so much more than that. A true surveillance system is going to have proper storage of whatever information. It could have motion detection in it. It can be using infrared. It could be sound-based. Surveillance systems can be smart locks that are keeping track. Everybody has a different 4-digit code to get in. So all of these collectively make surveillance systems work. So is a surveillance system Internet of Things? Yeah, probably, but it's just does surveillance. All right. The next one is voice over IP. So these are the VoIP phones that we use here in the office. Voice over IP basically just means that I'm sending voice calls over an IP network. Now, these are great, but this little phone right here, it is, again, it's got a CPU in it, it's got RAM in it, it's got an operating system. Here, you look on the back of this thing. Let me see if I can show this to you guys. Can you see that? It has connections to the network. I could connect this thing directly to the internet if I wanted to. Probably wouldn't make much sense, but I could. And these are also going to have certain security issues to them that are unique to any type of VoIP system. Now, the last one I want to talk about is probably about the strangest one that Security Plus puts in there, and that is what they call mobile systems. And after reading through the objectives, you can pretty much tell that CompTIA basically means things like laptops. Here's a tablet. It's a little iPad of mine. Battery's dead, but iPad. Or how about my smartphone? Yeah, I've got the old foldable phone. So when we're talking about mobile devices, at least in terms of what Security Plus is looking for, what they're trying to say is embedded devices that are mobile. That's really the only big differentiator. In my mind, from a security standpoint, I don't see a lot of difference between a Arduino and a smartphone, other than there might be some attack vectors that wouldn't be easy to do with an Arduino or a Raspberry Pi that are fairly easy to do with smartphones, primarily for more of the reason than there's lots more of these around than these. So bad guys tend to want to go where the good stuff is. But the important thing to remember, even if it's a mobile device, it's still embedded. It's got fixed amount of RAM, it's got a fixed CPU, it's got a fixed operating system. Yes, Mac, well, Apple will come and update it every now and then, but you're not going to be running Linux on this iPad. Not going to happen. And it has a specific type of use, and that is, in this case, to be a tablet. Make sure you're comfortable with these conceptually. Dan's going to be going in a lot of security issues on embedded type systems in other episodes, but by the time Dan is starting to talk about this, make sure that you in your mind can separate things like a drone from a Raspberry Pi. There'll be subtleties and differences that are going to make a big difference when we understand the security ramifications.